Well, welcome everyone. I have 6:30. I see we have several folks online. Everybody connecting okay? Yeah. Ready to get started?
You bet.
All right. Thought I'd give a short opportunity there if we had some connection issues. So again, welcome. I'm excited about this forage quality seminar we have this evening. Just to kind of get started here. My buttons work. Here we go. Welcome from the Indiana Forage Council. I'm Anna Morrow. I'm the program manager for Midwest Cover Crops Council and the current president for the Forage Council. The council is a group dedicated to research and education for profitable forage production and utilization. And our hay contest is a program we've done for a few years where we provide a discount on forage analysis and hope that we can encourage producers to do some testing, improve their production practices, and encourage better livestock nutrition. So just a few housekeeping items as we get started here. If you have questions as we go along through the different speakers, please type those in the Q&A, and you can find that under the More button. It's a little ... It says More. That will help us keep organized and keep your answering questions as the seminar progresses. We will check the chat, but the Q&A would be more convenient for us. We will hold the discussion and questions till the end, just to be respectful of everyone's time so that we end on time. If there are a few things that come into the chat that we can address quickly, we may take care of those as they come up, but the discussion will be towards the end. We are going to lock the Zoom room at about 7 o'clock. So new viewers will not be admitted if you happen to have a poor connection or some type of issue. We are recording the seminar, and so that will be posted and available later. You can follow us on Facebook and check out our website. We'll make that available at the conclusion. Maybe a couple of days, but we'll get it to you. And with that, I'd like to first thank our contest sponsors. So a big thank you to Hudson, SureTech, Cisco Seeds, Indiana Beef Cattle Association, Indiana Dairy Producers, and the Indiana Sheep Association. We couldn't do this without our supporters, and they're always very good to work with, and we appreciate them. I think most of the organizations have someone online on the seminar this evening, so I'm sure if you have questions or want to get connected with those folks, you can use the chat for that. Another big thank you to our speakers and organizers for both the contest and the seminar this evening. So big thanks to Nick Minton and Jason Tower. They've been instrumental in getting this contest pulled together and organizing this seminar. Really appreciate the work that they've done. Jason's hosting tonight, and we will hear from Nick later this evening. Also really looking forward to hearing from Keith Johnson, our Purdue Extension Forage Specialist, and Travis Roberts with SureTech on some of the technical sides of testing. I have to put in a quick plug on Indiana Forage Council membership. We always have a good time. You can read through some of our benefits there. We have a newsletter that goes out. And just a really good group, really good network of forage professionals and producers who are trying to better themselves and help educate neighbors. Please consider joining us. At the very least, follow us on Facebook so you can be aware of the events and opportunities we have coming up. With that, I'm going to turn the program over to Keith Johnson. And as our each speaker wraps up, we'll just let the current speaker introduce the upcoming speaker and just keep the evening rolling. So Keith, take it away.
Well, good evening, everyone. This is a special evening for me as we think about hay quality. And my presentation tonight is dealing with sensory analysis and sampling hay for chemical analyses. My contact information is listed there by email or phone number, and I try to be very responsive to questions from ag professionals and producers. So feel free to contact me if there's follow-up about this meeting or anything else related to forages. The objectives that I have tonight for the meeting are to define actually what forage quality is, the many things that affect forage quality, and sensory analysis, I think, is an important component of analyzing the overall quality of the forage. And then we'll discuss the proper sampling procedure for hay in terms of making sure that we get the most right information to the laboratory, and so that we get the results that are most accurate. It's very important to do proper sampling. So the definition of forage quality is an expression of the characteristics that affect the consumption, the nutritional value, and then following the resulting animal health and the performance of the livestock. To understand forage quality, we have to think about the physical characteristics of the forage, which are done by sensory analysis. It's more than sight. It involves touch and smell. And so we need to take into considerations the senses that are important to analyzing the physical characteristics of the forage. So these can detect concerns that you cannot tell by a chemical analysis. In other words, a chemical analysis is not going to tell us what a specific weed might be in the forage, whether it's toxic or not. It's not going to tell us necessarily, how moldy that hay is. So these are things, again, with sensory analysis that we use sight, touch, and smell. Now also a prelude then to Travis and Nick tonight when they talk more about the chemical characteristics, but this involves a laboratory analysis that ends up providing numbers to develop rations. And it's very, very important to follow through with the use of these numbers so that we can keep our livestock in the most healthy situation that they can be. This requires that we work with a trained nutritionist to make sure that the ration is developed most correctly. And so for most producers, probably they need to find somebody that's trained in forage nutrition to help balance that ration. This is one of my favorite stories of my career. And this is, let me tell you the story of I'm not eating it. And so this is a story that goes back to receipt of a phone call that said, Shepherd Bob said, my sheep are not eating this very, very nice quality alfalfa hay. And so I said, will you send me a few slabs of this hay, a couple flakes of this hay? And it showed up a few days later in a very nicely cardboard box. And I opened up and it was beautiful, beautiful alfalfa hay. The type of hay that you wanted to put your favorite salad dressing on. It was just very beautiful. So I put my hand into that box and I quickly withdrew it because there were the spines of Canada thistle. So I wondered about, okay, maybe the sheep are eating this hay. And I called Farmer Bob back, told the shepherd, I said, will you go out and look at the mouths of those ewes and tell me what they look like? And he did, and he called me back and says, well, they're quite blistered. And so this is a situation where chemical analysis would not have told us that we had a physical problem in the form of spines on that Canada thistle. And it's interesting to note, many times with lots of weeds, you may think that the analysis of the forage could be quite low, but that's not necessarily true with all weeds. As a matter of fact, a research study that was done in Minnesota several years ago indicated that Canada thistle is equal to, or frankly, just slightly better than alfalfa hay. That would not show up on a chemical analysis, but it certainly did show up in my hand. So for understanding forage quality, we have to complement sensory and chemical evaluation together. It's important to do both. So let's just talk about what affects forage quality. What are the factors that you as producers have to deal with in terms of making sure we get top quality of the forage as best as we can? I think the big factor is the maturity stage at harvest, and there on the right I have a picture of orchard grass that is fairly far along in its maturity. And so as crops are vegetative, you're going to find that they're higher quality as compared to a situation where if you were to take your fingers on the palm of that hand and thresh out some seed, you would see that it's overly mature for top quality. Actually, species also make a difference. Legumes, such as the red clover there that I'm showing in the picture on the lower right, is typically the legumes are higher quality than grasses. And so if we wanted a higher quality forage, we would look at inclusion of legumes with an adapted cool season grass. The other thing is variety within a species. And so I have several examples there of different varieties within the same species. So on the right is a sorghum plant that happens to be sorghum Sudan grass. And you can see that the midrib, okay, of that leaf blade has a brownish cast to it. And this is what we call the brown midrib. And it is a phenotype that indicates that this particular plant has less lignin, which is a structural compound that gives rigidity to the plant, but it's not digestible, and thus a lot of lignin is going to reduce the digestibility of that forage. So this actually was a mutation found at Purdue University back in the 1970s and was exploited then to be produced available to farmers in the 1990s, and has really become a standard bearer in terms of improved forage quality in the sorghum plants. The other thing is about tall fescue, which is a cool season forage. And, years ago, the only choice we had was high endophyte tall fescue. We presume that Kentucky 31, a very old variety, is probably high in that endophyte. Endophyte is a fungus that's internal in the plant that produces ergoalkaloids, which are very nasty in terms of the response of livestock and really all forms of their performance in terms of milk production, in terms of weight gain, increased body temperature, just a whole lot of things that can happen with that older variety. Along the way, research has produced low endophyte, which is less than 5% infection. This is in the seed, and the seed then grows into a plant that's infected. And what's even more amazing is that with technology, they've produced novel or friendly tall fescues that have an endophyte, but it does not produce the ergoalkaloids. And with that, it gives strength to the plant without the nasties of the ergoalkaloids types on livestock production. More recently, there's been the development of less lignin alfalfa varieties. And so typical amount of lignin in an alfalfa plant might be 7 or 8%, and varieties have been developed with a little less lignin, which again causes higher digestibility of the forage. Leaf to stem and leaf retention is critically important. We're showing there on the left a poor leaf retention. It's mostly stems, and on the right-hand side, you can see that the sample has definitely more leaves associated with it. So the greater the leaf to stem ratio that there is with the leaf retention of these legumes is going to provide a higher quality forage. And so what we're looking at here is proper moisture content, because if we're making the hay at a very low moisture content, we're going to find that we're actually losing a lot of those leaves to the soil in the baling process. And then we have the pests. And so on the lower left, we find the alfalfa weevil, which is a problem pest that we might have in the first cutting of the alfalfa crop. And then we can have many diseases like that showing of a leaf spot on the lower right there that can certainly cause leaves to take on the characteristics that you see there with lesser quality, and in severe cases actually fall off the plant. And of course, we do know that the leaves is where the dominant quality of the forage is found. And then again, some weeds. There are some weeds that are lesser quality than what we might find in a forage. The other thing is just mentioning the toxicity aspect again, is that forage quality can be reduced by things such as poison hemlock, horse nettle, those types of plants that have some poisonous characteristics, of which there are many that do. The environment and the weather plays into this. You all know about the battles with Mother Nature. She can be very pleasant, or she can be kind of like a witch when we're trying to make high quality hay with the proper maturity at the proper time. And that can get extended many times with the advent of rain, precipitation types, moisture, and temperature and sunlight play into this as well in terms of high quality or lesser quality forage. And then we can get into the situations of mold, where this probably occurred because we made the forage at too high a moisture content. Some heating can actually occur by the by the production of these molds. And the other thing that I'm showing in the lower right-hand picture is nitrogen deficiency in pre-tassel corn. So fertility plays into this as well. So the presence of foreign matter comes into play. So broken bottles, aluminum cans, sticks, excuse me. And many times when we get into the early fall, I've seen a lot of hay that is along forest edges, and we get a lot of leaves into the hay that can reduce the quality of the hay because of the presence typically of being very high in tannins in those leaves. The other thing in regards to baleage, which I'm showing there in the lower right, is a fermentation process of forage that's made about 50% moisture. We want to preferably have a pH that results after the fermentation process, which takes about three weeks or so to occur, to have a pH that's 4.5 or less. This is an indication that fermentation occurred well, that we've got the right type of acids associated with it, not butyric acid, but lactic acid is the preference that we have. And we also know that if a pH is less than 4.5, we reduce seriously the amount of potential of Clostridium and Listeria that can cause botulism and listeriosis. So this is really critical in terms of keeping your animals safe that eat this product. And storage conditions are very, very important. So keeping high quality hay under cover, not putting it along the edge of a woods on the side of where the forage field is very critical to keep quality. Actually, hay that's been in good storage over the course of many years can retain most of its quality, whereas as you've seen as you go about the countryside, know that you see many of these round bales in a situation where they're becoming more compost than they are quality hay. So just as a reminder, sensory analysis of forage quality is not just visual appraisal. We have to use the sense of touch, and the sense of smell can play into this as well. Although those of you with situations where you have allergies associated with different mold characteristics probably need to be protective of that, but smell is also an analysis of forage quality. One thing, I'm going to go back and make a statement that I did not in all those things that affect forage quality. One thing that we do know and become more critical about looking at in analyses that are received from the laboratory is the amount of ash that occurs. And essentially most of that ash, of some of which is always inherently in the forage, but a lot of the ash that comes into the sample is from soil contamination. In other words, raking, tedding too aggressively. And as a result, we find that we get some soil into that hay that increases the ash content, which reduces the quality of the hay. So I would say that a sensory analysis worksheet for the type of forage that you have with the fields and with the cuttings is not a bad exercise to do. This also is an excellent exercise for those of you that are in the education realm of thing to get several types of hay and then go through this process just for a good discussion of what we do see. And again, I think this has application for on-farm use to do that sensory analysis before you start feeding the hay so that you have an idea of what hays have a better quality than others, at least from a physical standpoint. So let's talk about the chemical analysis of forage quality. As with soil testing, a representative sample is very, very critical to have when we take a forage sample, and we want to make sure that we use a hay probe. Do not grab handfuls, because what's going to happen is you're going to have a lower quality of forage be reported by the laboratory if you take hand grabfuls, because what you're going to find is you lose a lot of the leaves, which again have most of the quality within that plant. So there are different types of probes, those with batteries, those that use electricity, a brace, which again is a tool that's used for drilling, but we can have the aspect of no use of battery or electricity with a brace. Or there are other types of probes that are available that we can do with manual force. Where I would go to look at the companies that sell hay probes is at that website of www.foragetesting.org. Very good information. Beyond that, certified laboratories will be announced there as well as just quality terms. So it's a really good website to view. I want to thank Tricia Herr. She's the Montgomery County extension educator, and she suggested that we develop a map that has available probes in our extension offices. And so this is available at the Indiana Forage Council website. And you can see that we do have a pretty good smattering of probes about. My guess is there's probably several others in here that didn't report to Tricia, but great opportunity to try to use one. I would hope as you go about borrowing it for a time or two that you will actually purchase your own probe so that it's more available for your use when it's really, really needed. So how do we collect a soil sample? Well, first of all, we randomly select hay bales from the same harvest within a field. That's called a lot. Same harvest within a field, provided that no environmental situations occurred, let's say overnight with a rainstorm and part of it the day before you baled it. Then, of course, you have two lots. You probe 2 cores from each of 10 large bales. And that what we find is we want 20 probings. So not 15, not 10, but 20 probings reduces the variation quite a bit in that number so that we feel like we're getting an accurate representation of a sample from that particular lot of hay. We probe 1 core from each of 20 small rectangular bales, and then we probe the butt ends of rectangular bales. Just a side comment on the young lady there and her approach of probing. Would like to have that more in a horizontal as compared to the angle that she has there, but you can see that she's at the butt end of a small rectangular bale. And would do the same then with the 10 large bales, but you would probe 2 cores from each of them. And then with large round bales, you probe the side curvature of round bales. And again, take 2 probings for each of 10 bales there to be your sample. So we want to place the corings in a clean resealable plastic bag, not a paper bag, because for proper moisture analysis at the laboratory, as you can imagine, if we send that through the mail, we're going to find that we're going to have loss of moisture occur in the process of being mailed in a paper bag as compared to that resealable plastic bag. Label the bag with information there that will be helpful to the laboratory as they put it into their record book. And then you can mail it or take it directly to a certified lab, which again is found at the www.foragetesting.org. And look up, please, the submission form that each of these laboratories have so that you can fill out information about the forage, when it was harvested, what is the type of forage, any underlying concerns that you have that may have affected the quality, where it was located, all these sorts of things. And really, this is where you can probably have a situation where you can think about having it be related to terms that you might call certain hay fields. So what type of test should be requested? A basic test normally is going to suffice, but we also then have wet lab techniques, okay, that are utilized, just really type of laboratory benchtop type of chemistry that occurs, or what was developed in the 1980s late and 1990s was a technique called near-infrared reflectance spectroscopy. And that's where we take a little sample and put it in a cuvette like this, and it's exposed to near-infrared light, and it gives a response back of quality based on calibration of equations that were developed by wet lab chemistry to give the equations that then allow us to use this near-infrared technique for use in terms of getting a forage quality result. So my major take-home messages this evening is that sensory and chemical evaluation are really complementary of one another. We don't want to use a hand grabs. We want to use a probe. And that forage quality is just as critical as soil testing to the success of a forage livestock business. I think most of our producers do an above average job in taking a soil sample, but we'd like to think that we get more response in terms of forage analysis to complete the whole process of determining what the quality is so rations can be developed to keep your livestock healthy. So again, my contact information is there, my email and my phone number, and I look forward to any questions you might have that we'll discuss at the end of the program tonight. But again, in the future, if you have questions, feel free to reach out to me. Okay. Thank you for your attention. So what we're going to do next is Travis Roberts is a individual that's employed by SureTech Laboratories in Indianapolis. They were extremely helpful in analyzing the forages that were submitted for the hay quality contest. But Travis, you're going to discuss the differences between NIR and chemical analysis, correct?
Yep.
Very good.
All right. Thanks, Keith. Let me go ahead and share my screen here. Is that coming through okay?
We don't have the full slide. So I think we got to go up to the upper left from the beginning or down to the lower right and get the screen type view.
How's that?
We have it.
There we go. Okay. All right. Yeah. Again, thanks, Keith, and thanks to the Indiana Forage Council for inviting me to speak tonight. I'm glad to be here. As Keith said, I work for SureTech Laboratories, a full-service agricultural lab in Indianapolis. We do feed, forage, and soil analysis as well as water and fertilizer analysis. My background is in analytical chemistry. I am the quality and technical supervisor at SureTech, so I'm responsible for new method development as well as just kind of overall maintenance of all of our lab equipment, as well as maintaining our NIR databases. As Keith said, the one thing we want to talk about tonight is NIR versus wet chemistry. And this is going to be a little bit heavier on the NIR side, just because in my experience, that's something that a lot of people understand a little bit less. So I want to explain a little bit about how NIR works. And I think that'll help us understand a little bit better when it may be appropriate to use NIR versus wet chemistry techniques. So I promise not to do too much chemistry tonight, although I feel I am a chemist, so I got to do just a little bit. And I think this will help us understand a little bit better the limitations of NIR. So just very brief, um, I think the important thing to understand is the difference between the two types of bonds that we see in a lot of compounds. Because one of these types of bonds is very responsive to NIR and one is not. And so we'll hit on that a little bit later on. But one is covalent bonds, and that's when two atoms share an electron. So that's so a good example of that is water. A lot of people, I know, have heard of H2O. But what happens in the case of water is that you have an oxygen sharing an electron with two different hydrogen atoms. That's a lot different type of bond than an ionic bond. An ionic bond, a good example of that is table salt or sodium chloride. And this is when an electron is completely transferred from one atom to another so that each atom is left with the charge. So if you think about the opposite poles of a magnet, how the positive pole of one magnet is attracted to the negative pole of another magnet, that's very similar how these ionic bonds work. Since in the case of sodium chloride, your sodium is going to be positively charged, your chloride is going to be negatively charged. So because of those opposite charges, they're attracted to each other, and that makes that bond. So as I go through these next few slides here, just try to keep this in the back of your mind as we start talking about NIR. So this is kind of an illustration of how an NIR instrument works. It's a very basic illustration, but it's actually pretty good. NIR instrument is basically these three components: a light source, a filter, and a detector. So that light source emits near-infrared radiation as well as visible light. But in the case of NIR, we're obviously more interested in that near-infrared region. So that filter chooses the wavelength of that light. And that sample, which is in this case, that brownish red substance there. But it could be any forage sample or feed sample or a variety of different sample types. That sample type is exposed to that near infrared radiation, and some of that radiation is going to be absorbed and some is going to be reflected. How much is absorbed and reflected, it really depends on what's in the compound or what's in the sample. So you see some of the compounds there at the bottom. Fats, which have that covalent carbon-hydrogen bond, are going to absorb some near-infrared light, as well as proteins, that nitrogen-hydrogen, as well as water and sugars. So the one thing you'll see here, all these are covalent bonds. So it's really those covalent bonds that absorb and reflect near-infrared radiation, not the ionic bonds. So again, just kind of keep that in mind as we kind of move forward here. And Keith touched upon this a little bit, that near-infrared is a secondary method of analysis, which means we need the wet chemistry to back up the near-infrared spectroscopy. So if you can imagine, if we are building an NIR database from scratch for, say, alfalfa hay, what we would do is gather several hundred alfalfa hay samples. And in some databases will actually have thousands of forage samples, and even in some cases, tens of thousands, but at least a few hundred samples of varying forage quality. And we would do wet chemistry analysis on every single one of those forage samples. So let's say we're trying to predict protein in alfalfa hay. We would do a wet chemistry protein analysis on each sample and feed that NIR spectra and that protein data into the NIR database. So what we're trying to do, it's a little bit like artificial intelligence. So we're trying to teach the software what good alfalfa hay looks like in NIR spectra versus bad alfalfa hay. So the graph you see here at the bottom, I know to the naked eye, this kind of looks like a bunch of squiggly lines. But if we look at enough samples, the software can start to pick out what, say, a 22% protein alfalfa hay looks like versus a 20. So if we scan a bunch of those higher quality alfalfa hays versus lower quality, it starts to see those differences. So then we scan our unknown sample, it takes that spectra of the unknown sample and compares it to all those spectra in that database. And it'll say, okay, this spectra looks very, very similar to that high quality or that 22% protein alfalfa hay. So it'll predict 22% protein. If it looks more similar to that lower quality or that lower protein alfalfa hay, it may predict something like 18 or 19%. Or of course, if it's somewhere in between, it'll predict that as well. So it's really a lot. The work of NIR is really building these robust models. And it's not just a high number of samples in your database, it's the right types of samples. You don't want just all good, high quality alfalfa hay or poor quality. You want a good broad spectrum of alfalfa hays in your database so you can predict samples of various quality. So the why, some of the benefits of NIR versus wet chemistry. Rapid turnaround time. If you send a sample into our lab, if you get an NIR only package, most of the time you'll get that analysis back the same day it shows up at the lab. That's because all those NIR databases, they've already been built. So what we do, we'll receive the sample, we'll dry and grind it, and then we'll scan it on our NIR instrument. And standard scan is about 30 to 45 seconds. And so it'll gather that spectra, compare it to thousands of samples in the NIR database, and do a prediction of several different constituents in that alfalfa hay sample or whatever forage sample you're sending in. Decrease sample handling and preparation. Obviously, it's the NIR method because you're just dumping the sample into a cup and scan, and there's a lot less steps. Decrease cost of analysis. And NIR packages are usually a lot cheaper. They're non-destructive, which can sometimes be a benefit for small samples, because once you analyze that sample, you can just dump that sample right in the bag, especially if you don't have very much. And improve repeatability and reproducibility. That goes back to how easy the NIR method is to run compared to wet chem. Some of these wet chem methods they're multi-steps, very laborious, and so they're just a lot greater chance of error. And so while the wet chem method may be more accurate many times, a lot of times it's easier to get the same number over and over again at NIR just because it is such an easy method to run, and also environmentally friendly because you don't have the chemical cost or the chemical waste with NIR as you do several wet chemistry methods. So why do we run wet chemistry at all in any forage? Most of the time, the NIR is plenty good enough for almost all constituents. And Keith mentioned that earlier. Usually the basic packages, which are usually your NIR packages, are good enough. But if you have a particular concern about mineral concentrations in your forage, NIR may not be the best option because minerals like calcium, sodium, magnesium, potassium, they're present in the forage due to the ionic bonds that we talked about earlier. And those ionic bonds are essentially invisible to the infrared radiation. So the NIR is really not going to see those minerals very well. Having said that, however, you've probably seen NIR only packages and you've seen minerals being predicted from those packages. And the reason why we can do that is because even though the NIR cannot see the minerals itself, a lot of times those minerals have an impact on those covalent molecules that are present in the sample. So in this example, water is a very strong near-infrared absorber because of those covalent bonds. Sodium is essentially invisible, but if a sodium ion is present in the sample, it may impact the way these water molecules or these covalent bonds interact with the near-infrared radiation. So we can kind of indirectly estimate the amount of sodium present in the sample. So when it comes to picking a package, usually these NIR packages are good enough. And this is one of our forms that we have at SureTech Labs. If you're not overly concerned with minerals and mineral estimates will suffice, to go with one of the NIR packages. They're usually a little bit cheaper. And NIR is very good at predicting organic compounds such as fibers, fat, protein. And again, the mineral estimates are a little bit better than what you might think because of those indirect measurements. However, if you are very concerned about minerals, let's say you're doing a DCAD ration, so you're really concerned about cation-anion ratio, or you have hypocalcemia concerns, or you're worried about some other nutrient or mineral deficiency in your ration, then you may want to add on a mineral package. Anytime you add on a mineral packages, all those mineral packages are done wet chem. That would be kind of the advice I offer people. NIR only is usually good enough. But if you're a little bit more concerned about minerals, then I would suggest a wet chemistry add-on. And I think the one other thing that I want to mention about when we might suggest wet chemistry is if we have a sample that for some reason doesn't match the database very well. And the NIR software actually tells us that. So when we scan that sample NIR, the database will actually tell us, I have very high confidence in this scan because there's a lot of samples in the database like this sample, or it'll tell us there's very low confidence in this data just because there's not very many samples or no samples like this in the database. And that's a situation where oftentimes we'll reach out to the customer and we'll say, we'll give you the NIR data, but just so you know, the confidence is not as high as you'd like for it to be. So we recommend you upgrade to wet chemistry analysis. That's kind of rare that happens, but it does happen occasionally. So I wanted to mention that. Yeah, so thank you for your attention, and for then my contact information is here. So if anybody ever does want to send a sample into our lab, you can go to our website here to look at our request forms, or email our customer service team. And then if you have technical questions, feel free to reach out to me, and my info was there on that last slide. So that's all I had.
Well, thank you, Travis. Just as a reminder, we want to make sure that if you have questions, that you put them in the Q&A. Again, go to the More tab with the ... and there'll be a question and answer Q&A. Type it in. I'll keep track of those, and then when we get to the end of the meeting, we'll have full discussion here for a little bit of time. So again, thank you. The next individual that I will introduce is Dr. Nick Minton. He is a beef systems specialist located at the Feldon Purdue Agricultural Center, which is located just a little bit west of Bedford. And Nick, you're going to give us a presentation here as we get into navigating forage analysis. And Nick is definitely trained as someone that can balance rations. He's a type of individual, along with those in the industry, that can be helpful to you once you receive those forage test results. So Nick, it's yours.
Thank you, Keith, for the introduction. Can you confirm that you can hear me and see my slides all right? Good deal. Thumbs up. All right. Hello, everybody. Had a good presentation so far tonight. So next is, we've gone through sampling your forages, we've gone through the differences in the analytical procedures that we can take. And so now you have your report, whether it's an NIR report or a wet chem report. You have this list of several things that are outlined on the report, and it can be overwhelming, especially if you don't look at the analysis as frequently as someone like myself or Dr. Johnson, or someone else who spends a lot of time with ration formulation software, or someone at a laboratory. That's completely all right. If I go to a doctor and I have some blood work done, that's not an area that I spend a lot of time in, and I need someone to, help me navigate that analysis. Or if I'm taking my car into the shop and have to have some diagnostic work, I rely on those folks to help me navigate what needs to be done and develop a plan going forward. And that's really what extension is about. If you have a good relationship with your local feed mill and a nutritionist there, those folks are there to provide that service as well. And so with that being said, what we're going to do is the next several slides are going to go through kind of the major points of the forage analysis, the biggies, I guess, if I'm thinking about it, in making some sense of what's on that report to identify what the forage quality is. And with that, what we're going to do is how I sequence these slides and the analysis or the assays I meant. We're going to go in order as they're laid out on one of SureTech's reports. And so what you're seeing here is we're going to start with moisture. Moisture is typically always at the top of that report. And the important thing is that we want to know the moisture content for the information on the slide, but also when we're looking at the nutrient concentration, we have to be looking at it on a dry matter basis because there's going to be a difference between the as is and the dry matter. And so when we're talking about ruminant diets, we need to be looking at it on a dry matter basis, and we'll talk about converting it back to an as fed later on. And so with hay, the ideal range is between 18 to 20%. If we get it drier, then we're going to have some leaf loss. If we get it too wet, we're going to have potentially some spoilage, and unfortunately also the risk of fire. And that's what the table heating, I should say, heating and fiber. And that's what the table here to the right shows is those temperature ranges. If we're less than 125 degrees Fahrenheit, we can sleep easy at night and go on about our business. But if that hay is heating to temperatures higher than that, then we need to be monitoring that closely and then taking necessary action when we get into these exceptionally hot conditions. Now for baleage, baleage is a higher moisture content forage than hay. The sweet spot is between 50 to 60% moisture, but generally we're going to see them range between 40 to 60%. When we run into moistures with baleage that exceed 60%, that's when we're going to have poor fermentation occurring. Simply, there's too much moisture there. It's going to buffer that lactic acid, that the lactic acid producing bacteria that are there naturally on the forages. We rely on them to convert sugars into lactate and lactic acid to drive that pH down and preserve that forage. If it's too dry, on the other hand, again, we're not going to have an ideal forage or an ideal fermentation, but we're not going to necessarily have some of the Clostridium risk of the Clostridium bacteria, as Keith mentioned earlier. But one indicator of poorly ensilaged baleage is whenever you open that wrap and if it has a kind of a putrid smell. In addition, that would be in one of those sensory analysis that you would pick up on. That it would need further evaluation to see what the quality is. Protein. Protein is always a big topic of conversation when we're looking at any type of forage analysis or other ingredients. Crude protein, or it might be just simply referenced as protein, is typically the first one. Crude protein is a combination of true proteins, or the combination of amino acids, individual amino acids, nitrate, and non-protein nitrogen, which is urea and ammonia. Now, adjusted crude protein comes into play when we're talking about bound protein. Now, there's naturally bound protein in forage that's bound to lignin, but there's also bound protein from excessive heating. And so, what studies have shown is that when the adjusted crude protein is greater than 10% of the actual protein or crude protein value reported, then we have some excessive heating. Or if the acid detergent insoluble protein, commonly referred to as ADIP on the report, if that's exceeding 20%, then again, that's more than just naturally bound protein, and the hay has gotten hot and has caused the Maillard reaction and has bound that protein. Then that protein is no longer available for absorption to the animal. Soluble protein is our indicator of potential rumen degradability. That's important when we're talking about supplying protein to the rumen bacteria. It really comes into play in terms of ration formulation software. Fiber. The two components of fiber that have most interest in would be neutral detergent fiber and acid detergent fiber. And so for the remainder of this presentation, I'm going to refer to both as NDF or ADF. And so neutral detergent fiber, the fiber fractions include hemicellulose, cellulose, and lignin. Now, neutral detergent, or I'm sorry, hemicellulose is soluble, meaning it breaks down in an acid detergent. And so after we're done with that assay, we're left with cellulose and lignin. And so the important components here is that the rumen microbes break down hemicellulose and cellulose to an extent and provide energy to the ruminant animal. That's the unique thing about the rumen bacteria. Now, when we go thinking more about NDF and ADF, NDF is our indicator of intake potential. And so the lower the NDF, the higher our intake potential is. And so when we're looking at this diagram here, more vegetative forage or a greater leaf to stem ratio, we're going to have a lower NDF, which means that the animal can consume more of that forage. However, when we're talking about acid detergent fiber, or I'm sorry, ADF, it's indicative of digestibility. And again, the lower the ADF, the higher the digestibility. And so as this diagram illustrates the stages of maturity of a forage, as the forage matures and it gets more lignified, we see intake potential go down as well as digestibility go down because NDF is increasing and ADF is increasing as forage matures, which is outlined here in these two shaded boxes. Now, getting more into the weeds on NDF is NDFD, and that stands for neutral detergent fiber digestibility. And where these digestibility estimates for NDF come into play is again in ration formulation software, where instead of utilizing what we're going to talk about here in a minute is TDN as our energy predictor, we can include the NDFD at either a 30-hour or 240-hour assay, and the software will predict or adjust energy supply to the animal based on those assays. And so when it says NDFD 30, that means that it's been that forage has been in a in vitro benchtop procedure. We put the forage into this container that has rumen fluid, and then we measure digestibility up to that 30-hour mark, and that gives us our NDFD. Also, it could be said for NDFD 240 or some other hours, 12, 24, and etc. And so in the dairy industry and depending upon the nutritionist or the formulation software that they're working with, these values may be of more interest to them. And that's really based on their, how they're predicting, or the software that they're utilizing to predict nutrient supply to the animal based on fiber digestibility. Outside of fiber, we also have non-fibrous carbohydrates, the NFC. And so that includes starch, sugars, and pectin. Our method of estimating energy supply from the forage comes from TDN, or total digestible nutrients. And that's a calculation. It's the sum of the NFC, the NDF, crude protein, fat, minus the ash. And so, but it's special to note that you can't take your forage analysis and sum all of these different components up and arrive at your TDN, because it takes into account the truly digested component of each one of these. And so anyway, that is the formula for calculating TDN. But when we're wanting to get to kind of, again, more into the weeds on energy supply to the animal, net energy is going to give us usable energy provided by the forage, or any feed stuff for that matter. Net energy can be broken down into maintenance, growth, and lactation. and are denoted by NE, M, NEG, or NEL on a forage analysis. Those are measured on a megacal. It may be megacal per pound. It may be megacal per kilogram. And so sometimes you have to convert kilograms to pounds, and so, or vice versa. The reason the net energy or NE system came about is that it accounts for the microbial contribution to ruminant diets. And that's really one of the key components of its differentiation from just a calculation of TDN. We've heard already about ash, and so the inert material that can find its way into our forages. So from soil and sand and rock, if anybody was, putting up, maybe a fourth or fifth cutting hay in this part of the world this fall or late fall, we were rather dry, and so I would anticipate just from that we might see some elevated ash levels in those forage analysis. But again, greater than 10% is considered excessive contamination, and it's associated with too low of cutter bar height, too low of setting on the baler pickup, rake, or the tedder. Even though we have some hydraulic, those pickups these days can be hydraulic, we do need to be paying attention that we put in necessary blocks or the manual adjustment to make sure that we're not picking up it consistently. We're not consistently picking up soil into our hay or our baleage. On ground-driven wheel rakes, we need to be cognizant that the ground pressure is not too excessive to, again, where we're bringing in excessive soil. At times, if we're baling in wet conditions or even dry conditions, both of which can cause excessive ash content in forages. When we're talking about baleage, some other components on a forage analysis that are important would be water-soluble carbohydrates. And so higher the better. And that's because the more water-soluble carbohydrates we have is more of a food source for those lactic acid bacteria to break down those carbohydrates and drive that pH down quickly and cause the preservation of that baleage more rapidly, which is the quicker we can get it preserved or the pH down is when it's most stable. Keith already mentioned about the importance of pH. And the thing is if we're outside of this pH of 4.5 and we have excessive moisture or too dry of a baleage, then it's worthwhile, if we haven't done so already, to go ahead and have the sample evaluated for fermentics that would provide us with lactic acid content, acetic acid, or butyric acid. And the ranges are for both lactic acid and acetic acid will vary depending upon if it's a grass or if it's a legume, and so just need to be aware that there are some differences there, and these are provided on tables on some extension publications or some other laboratories. Butyric acid is relatively consistent across the board in terms of ideally we want to see that less than 0.1%. And so if we see that at greater than 0.1%, then I would be inclined to say that baleage is suspect to potentially not being able to be fed to livestock. Another indicator of quality baleage would be the percent nitrogen as ammonia, with the goal of it being less than 0.15%. So for the RFQ and RFV, both are ways to grossly evaluate the forage quality. So RFQ, or let me start by saying RFV is relative forage value and relative forage quality is RFQ. Now, the primary difference is that relative forage value, or the RFV, came about first. And it was an ADF based formula structured off of alfalfa. And so if we had an RFV value on grass, or if the RFV value on grasses would not be accurate because it's being compared to a formula that was based off of alfalfa. And so that was really the driving force behind coming up with RFQ that differentiates between legumes and grasses. It also takes into account intake potential of both forages as well as TDN digestibility, which RFV does not. So it's more of a robust estimate of forage quality, and both are convenient tools for pricing forages. All right, so now that kind of the next step of my presentation is going into discussion on selecting forages by production stage. So you have your forage analysis, and now what? You know, you've interpreted it, we've talked about it, or you talked about it with a nutritionist, and so how are we going to feed it? You know, if you only have one lot of hay and that's all you have, well, we still have to be aware of how that hay is going to match up with the nutrient needs of our livestock. And so, real quick, if you don't have a Purdue Forage Field Guide, I highly encourage you to get one. Those can be found at the Purdue Extension Ed Store. You know, it's in excess of 300 pages of highly valuable material when it comes to the forage production. It's handy. You can carry it obviously in your pocket, put it in the baling tractor or whatnot. But in addition to just the forage quality parameters, there's a wealth of knowledge or information in that booklet. And so when we're talking about forage quality and meeting nutrient requirements of livestock, on pages 269 through 281, that's where there's a handful of tables there for multiple species of livestock that talk about this subject. So what we have here, though, is what this figure is illustrating is the difference in energy and protein requirements of a beef cow over the course of 12 months. And so the black bars indicate protein or energy requirements of the cow, and gold bars are the protein requirements for the cow in reference to the month of the production cycle. So month number 1 is referring to calving. Month number 3 is reference to breeding. And so you can see there's fluctuation throughout the year. And our job as managers of livestock is to do our best to provide them with the ability, do everything that we can to allow them to meet their genetic potential for whatever aspect of production we need them to perform at, whether it's putting pounds on calves or ewes or kids, or putting milk in the tank. And so, as you can see, which might most likely is not surprising to anybody, but over the course of the year, you know, they're fluctuating. And so when we're talking about in terms of hay nutrient requirements from a beef cow, the first and second trimester, there's not a lot of difference in terms of nutrient requirements during that point in time. And so an adjusted crude protein of 8% and TDN ranging between 50 to 53%, we should be able to meet the requirements of those animals. But as that fetus begins to grow in the latter portions of the third trimester, obviously nutrient requirements are going to start increasing. And so adjusted crude protein bumps up by 2 percentage points to 10%. We see a similar increase in TDN going from 54 to 57%. So higher quality forages or more intake potential is going to be needed in this third trimester. But the challenge with increasing dry matter in that third or intake potential in the third trimester is as that fetus grows, it's taking up space. And so, you know, the gut is going to be restricted to some degree based on the size of the fetus. And so higher quality forage becomes even more important later on in gestation for that reason. And then once that rascal hits the ground, then we really see our highest nutrient requirements with an adjusted crude protein. If we're in that 12% range with a TDN of 57 to 63%, we should be in the ballpark. Well, if not, if we're not meeting these, if we're not in this range, then obviously we're going to start to see some decline, reduction in performance by the animals. When we're talking about cattle in particular, we may have a struggle with them rebreeding. Cattle are the only species that we're asking them to rebreed when their nutrient requirements are greatest. I mean, they're right in the middle or coming just off of peak lactation. And so that is always going to be working against them. We see similar trends, but in other livestock though, with, as they fluctuate through different stages of production. And so for the ewe, for example, ewes or nannies are going to, typically we're wanting them to have multiples, and so that influences their nutrient requirements. However, during maintenance and breeding, whether they're having a single or a twin doesn't matter because they're not bred at that point. So nutrient requirements based on the number of offspring that they're going to have are not influencing the requirement. However, as they progress closer to breeding, we do need to increase the nutrition so that we are preparing them to breed. And once they are bred, that's when we start seeing the differentiation in both energy and protein requirements based on the number of offspring that they have. And so, as I mentioned, the energy requirements are reported in megacals per day. Metabolizable protein is, again, a more in the weeds measurement of protein. So metabolizable protein is the utilizable or what can be absorbed by the animal, whereas crude protein does not differentiate between what can be digested or absorbed from what is not absorbed. So, in terms of one thing I want everybody to think about for just a moment is with dairy cattle or dairy goats for that matter, why could a forage change or an adjustment be made sooner compared to other ruminant species? What's different that will allow between dairy cattle and dairy goats us the opportunity to make a more rapid change compared to other species? I would argue that it's because we can see the amount of milk going into the tank within a couple days or within the first week of them lactating, or if they've been in lactation for several weeks. If there's all of a sudden a difference in the amount of milk coming into the tank, then we know that there's something from a management perspective, a health perspective, or the diet, and i.e. forage, potentially the forages that we're providing to them, is influencing their milk production. Now, when we're talking about beef cattle or sheep or goats, more geared for producing meat animals or pounds of animal, it's drastically more challenging to see that within a couple days or a couple weeks. Typically, it's within possibly a month, maybe a couple months. Might even be all the way to weaning that we, at that point, realize that something influenced the weight gain or the body condition on those animals. Which leads us into the conversation of why are cows, ewes, or does losing body condition, especially when they have access to hay at all times. And obviously in these pictures, we're providing hay in a ring, but it may be that we're unrolling it and unrolling it out into the pasture. Nonetheless, over the years, if that's caused you to scratch your head a little bit, and I don't understand why they always have feed in front of them, but they continue to lose condition. And at this point in the presentation, you might be putting together that, well, it's probably because my hay doesn't have high enough nutrient content, which is true. But what we're going to focus on here is in the next couple slides is the intake potential of these forages. And so what we have here are two different piles of hay. They're both from the same bale. So I want you to just take a minute and study that picture to see if you notice anything different about these two piles. Ignore the environmental surroundings. That has nothing to do with the two piles. But see if you notice any difference between the two. If you're curious about what the nutrient composition is of these forages, that's provided here in this table here. And so now that you're a little bit more familiar with the acronyms, we have dry matter, crude protein, adjusted crude protein. This would be the acid detergent insoluble nitrogen, fat, ADF, NDF, lignin, NFC, ash, relative RFQ, TDN, and then our NE values here at the very bottom. All right. So now the hay piles are still in the same orientation. It's the same pile on the left, the same pile on the right. But so what's the difference between the two? The difference is that one's bigger than the other. One weighs more than the other. And so the pile on the left weighs 54.9 pounds and the pile on the right weighs 29.8. So what's the difference between those two? Well, the difference is that one pile is what a cow needs to consume, and the other pile is what the cow is able to consume. And so these piles or these weights were predicted with the assumption that we have a 1,300-pound beef cow that is a month post calving, and based on her nutrient requirements in that stage of production. And so again, so how do we arrive at these weights? And I don't know how else better to do it than to go through some math. And I promise there's just a couple slides of math, but this will prove that we just didn't grab these values out of the clear air. So as a rule of thumb, an animal can consume, beef cow can consume, or actually we use the same rule of thumb or the conversion for cattle, sheep, and goats, that they can consume 1.2% of their body weight in NDF on a dry matter basis. And so instead of using the 1.2 from a mathematical perspective, we just remove the percentage and so use 120. So we take 120 divided by the NDF of this hay, which was 62.75. That tells us that that cow can consume 1.91% of her body weight in NDF on a dry matter basis. So recall, we have a 1,300-pound cow, and she can consume the 1.91% of body weight in NDF on a dry matter basis. That means that she can consume 24.8 pounds of dry matter of this hay. But we think back to one of the initial slides that I brought up in terms of moisture. And when we're talking about ruminant diets, we have to convert that. We have to convert to dry matter, or we have to convert to as fed. So as fed is the bale sitting on the ground. So the bale sitting in the field is on an as fed basis or an as is. The bale sitting in the feeder is on an as fed or an as is basis. And so when we can take the dry matter intake and divide it by the percent dry matter of the forage, we arrive at 29.8 pounds. And so if we have a 1,000-pound bale, this cow is able to consume 29.8 pounds per day of this hay. So now, how do we arrive at the 54.9 pounds? So we can go to the nutrient requirements of beef cattle, or you can find an extension publication online, or even the Forage Field Guide that's going to give you some indicators of what the nutrient requirements are for livestock at that respective stage of production. And so for this 1,300-pound cow, a month post-calving, her daily requirement for crude protein is 2.84 pounds. Okay? So recall, when we're talking about nutrient delivery to the animal, we have to be doing that on a dry matter basis. And so the cow is consuming 24.8 pounds of dry matter of the hay. So we take 24.8 pounds times the percent crude protein of the forage, which is 6.2, and we arrive that the cow is consuming 1.54 pounds of crude protein per day, but she requires 2.84, which puts her at a net loss of negative 1.3. Okay. And so for her to, so how much of this respective hay would she have to consume to reach that 2.84 pounds of crude protein on a daily basis? Well, we take the pounds of crude protein required per day, divide it by the percent crude protein of that forage, and that puts us to 45.8 pounds of hay on a dry matter basis. But again, we have to convert that to an as-fed basis. And so that's where we arrived that the cow would have to consume almost 55 pounds of hay to meet her crude protein requirement. But we have to also take into consideration that there's an energy requirement that needs to be made. And so the NEM requirement is 16.2 mcals. And so we go through the same math. The cow can consume maximum 24.8 pounds of dry matter. We multiply that by the NEM, the megacals per NEM megacals per day of the respective forage, which is 4.47. And that equates to 11.7 mcals of NEM supplied. But she required 16.2, puts her at her net loss. So how much of this respective hay would she have to consume to meet her energy requirements? We take the megacals required divided by the megacals supplied in the hay on a dry matter basis, and that arrives at 34.5 pounds of dry matter. When we convert that on an as-fed basis, it arrives at 41.4 pounds. Well, that's less than what the 54.9 pounds was for the crude protein, right? But when we're balancing diets and for livestock, we're always going to feed the meat the most limiting nutrient. And in this case, it's crude protein, which is why they have to consume almost 55 pounds of this hay. All right. So just as reference, we have hay number 2 here. Again, both piles are from the same bale. And so here's the nutrient analysis for this hay. And so note if there's any differences between these two piles, or if you note any differences from hay number 1 that we just talked about. Again, piles are oriented in the same manner in terms of left to right. So what's the difference? Excuse me. Well, the difference is that the pile on the right is 43.4 pounds and the pile on the right is 32.2. And the pile on the left is what the cow is able to consume, and the pile on the right is what the cow needs to consume. So in this case, higher quality forage, the cow simply doesn't have to consume as much of hay number 2 to meet requirements as she does of hay number 1. And so when we're thinking back to strategically feeding hay, meeting requirements at different stages of production, these are the steps that we're going to navigate through. And so given that this cow is 1 month post calving, we would feed recommend that you feed hay number 2 first, and then after she enters into a different stage of production, then maybe hay number 1 might be meeting requirements. And so we're being more efficient in our hay use and meeting requirements on a daily basis for those cows. The challenge, so what's the challenge with lower quality baleage? In that, well, it's lower dry matter intake. And so it makes when we have lower quality baleage, it makes the problem even worse because we're already dealing with a wetter forage. And so they have to consume more to meet their dry matter requirements. And so if the quality isn't there, we're going to see condition or performance drop even more rapidly, I would argue, with baleage compared to dry hay, because we have to account for that additional moisture. And so we just you need to be really aware and be diligent in testing baleage to make sure that we have a firm understanding of what the quality is of that prior to providing that to any livestock. And we actually ran into the case I did several years ago when I first was introduced to excuse me, baleage, that cows were actually losing condition, and the quality was moderately good, but still on a dry they couldn't consume enough, and so we ended up having to put some additional dry hay out there to supplement that to stabilize body condition. And so this is kind of an excerpt that I found come across from Dr. David Lawman out of Oklahoma State, and I thought it was really good. Weight and condition loss between birth and weaning is a good indicator that the animal's maintenance energy requirement and/or genetic capacity for milk production is beyond the capability of the grazing resources. Now, this says grazing resources, but I think you can easily input hay into this this context. And so what this is in summary, if we find ourselves in a situation where we say, we can't produce any higher quality hay or we can't source it, then we have to go to the next logical step if we're still not meeting objectives of the operation, but to see if there's something we can do from a management perspective. And that may entail seeking different genetics that will meet expectations based on the forages you're producing on your operation. And so the take-home message here is that understanding the quality of hay or baleage prior to feeding or purchasing is very, very important in helping your livestock meet expectations that you have for your operation, and organizing your forage inventories to strategically feed them throughout the course of a production cycle is an efficient way for you to efficient for your monetary investment there, and also your time in either producing it or sourcing it. And with that, here's again my contact information. I appreciate the opportunity and your attention tonight. Anna, I think I'm going to kick it back to you.
Sorry about that. My computer was delayed a little bit. All right. Well, thank you to all of our presenters and also our host sites if you're meeting in person. I am going to share this QR code just really quickly. This will be available on the next few slides. So if you don't get it on this one, you've got another couple chances. Our extension host, it will have some printed surveys if you prefer to do a printed survey as opposed to scanning the QR code. Please consider doing that survey. It's very quick and it helps provide us some input so we can continue to have some good programming for everyone. And again, hosts, please send those printed surveys back to me and your attendance numbers to Crystal Paris, and we'll keep track of all that. Now for the exciting part of the evening, we've got our award winners. Some statistics from the competition this year. We had 71 samples submitted, and those were from 26 different producers and includes 16 different counties. So just really quickly, these entries were judged by NIR from SureTech Labs, like we heard about earlier this evening, and they were ranked on the basis of relative forage quality. And then, if there were any ties, we broke those accordingly. We will be handing out cash prizes for these. So the checks to our award winners will be mailed probably early next week. Please be in touch if it's much later than that, so we can make sure that those get handled. So moving right along, our grass hay competition. First place went to Grant Weyer, Du Bois County. Second place, Lauren Kuhn, Montgomery County. And third place was another hay from Grant. So congratulations. Next up is our legume hay. First place, Martru LLC from Marshall County. Second place, Leslie Swindell from Hancock. And also third place. Some nice numbers there. All right, our mixed hay, first place will go to Troy Shipper from Miami County, excuse me. Second place, Wesley Swindell, Hancock. And third goes to Roger Robinson from Orange County. So that was our hay competition. We also had a baleage competition. So grass baleage, first place went to Kevin Abbott out of Clark County. Second place, High Stakes Farm, Clark County. And also third place. So congratulations. For legume baleage, we only had one entry, and that first place prize goes to High Stakes Farm again. For our mixed hay baleage, we've got first place going to Kevin Abbott in Clark County. And again, second place to High Stakes in Clark, and High Stakes again for third place. So again, congratulations to our winners. We'll get those checks out as quick as possible. And I'll leave the QR code up for a little bit. I know we had a few questions come into the chat, and if I can change my screen around here, I'll get those.
Okay. Just roll them up. Thank you.
All right, we had one question. When should hay be probed, before or after curing?
Yes, the hay should be probed after curing for best results, because certainly some things can happen between the time that the hay is made and the time frame of getting it to cure, which you know, you can harvest that hay, as Dr. Minton indicated, at about 18% for large round bales and maybe 20% for small rectangular bales, maybe 18, 16% for the large rectangular bales. But you'll find that over time, after the curing happens, we equilibrate down to about 12 or 13%. So there's some loss of moisture that occurs. Actually, some of those cells are still living, and so respiration can occur during that respiratory process for at least a little bit of time. So the right time to do it would be after curing.
Keith, can I add to that just a little bit?
Sure, absolutely.
If especially on like the baleage, if you're not really sure of what your moisture is, if you don't have a moisture probe or sensor on your baler, if you go ahead and take some samples prior, at baling, and send it off to know what the nutrient analysis is going in, then it gives you an idea of what the moisture is, if you need to expect anything prior to feeding. But like I completely agree with Keith that it does need to be probed after ensiling, or as close to the feeding as you can get it.
And if it's being stored for any long period of time, probably closer to the time of feeding is better too as well.
Yeah, so I think what Nick brings up, just a little bit of a follow-up there, is maybe you should think about learning how to use the microwave oven technique or the forced air type of small dryer that's available. I think the most common one's probably manufactured by Delmhorst. There also then is from Penn State University, one that interestingly uses a hair dryer.
I think Keith might have froze up. Is that right?
Yeah, I think so. Yeah, there's a few different at-home methods for drying hay to get that rough moisture estimate. Looks like I think we may have lost Keith altogether. We've got some more questions here. Anyone have a recommendation on publication that helps to explain forage analysis?
Keith's here.
Okay, good.
Yeah, so I'm thankfully, my great extension assistant, Crystal Paris, is here tonight to keep me out of trouble. And I appreciate her very much. The one that I think really does an outstanding job is one that is out of Wisconsin. It's called Understanding Forage Quality, just kind of like the question did, Understanding Forage Quality. If you were to browse Understanding Forage Quality and put Wisconsin in there, it came up for me. For those of you that have pens, it's FYI dot extension dot WISC for Wisconsin dot edu. But I think this is a 20-page document that's really a pretty good read for producers and ag professionals. Has a really good starting point, fine glossary in it, some fine graphics, good pictures. So that'd be the one I'd recommend.
Thanks, Keith. What about a cattle ration software? I know we talked about a few last week.
Yeah, probably the most user-friendly one would be Brands out of Iowa State. I've heard of a program called Cowbites. I've not worked with that one. I tend to work the most with Brands growing cattle. I use some software that we developed while I was in grad school. But with those ration formulation programs, they're good. And there's you just have to understand how to use them, and where your limits are. Because if you don't know where your limits are on certain nutrients and intake, then you can get in some digestive upsets relatively quick. But there is the Brands program. There is a producer model or producer version, and then the professional editions more for folks that are doing a lot of probably more consulting, probably feed mill or whatnot. Someone that has a little bit more formal training. But yep.
There was a question on Q&A, not through the chat, but Q&A. The question was, if we have to mow overly mature forage, essentially, should we mow it back to 4 inches or leave it taller? I would say that whether it's overly mature or immature, that probably mowing at the right height for the forage that you're working with. I wouldn't necessarily think a standard bear needs to be 4 inches. As an example, not that there's much of that utilized in a hay resource, but even in a grazing situation, if you have bird's foot trefoil, the legume, you always want to leave some basal leaves when you harvest that one. Or if you take it down to, say, 2 or 3 inches, like you might with an alfalfa crop, you're going to lose the stand. But for a typical cool season grasses, yeah, I think 4 inches is probably a reasonable height to consider. One thing that was obvious a few years ago is that many people were mowing an orchard grass and alfalfa mixture and getting it down to a relatively low height, say of 2 inches, which alfalfa can take that, but orchard grass where its reserves are stored are really at about 3 inches in height, that you're taking away the energy resource that allow growbacks. So again, definitely I think 4 inches is appropriate for orchard grass and most cool season grasses. Then we can come to things like sorghums and millets. Really, we need to be harvesting them about 6 inches. So I'm not sure the maturation plays into this, but certainly the species of forage does.
Real quick, and I forgot,
Q&A.
the University of Kentucky also has a web-based module primarily for predicting requirements for beef cows and supplementation. I'll put a link to that in the chat for everybody. But it's if you Google University of Kentucky cow formulation, ration formulation software, it should come up.
Great. Any more questions? Please put them in the Q&A. We did have one during the presentation that asked about nutrient requirements for beef and whether or not that was supplementing with grain. Hopefully we kind of cleared that up, that we're calculating without supplements just based on the hay, and then determining whether or not a supplement is required. So if there's any clarification needed there, please type it in the chat or the Q&A. Well, we appreciate everyone joining this evening. I'm not seeing any more questions. Most of our presenters have shared their contact information. Please get in touch with your extension educator if you need to follow up with them or one of our presenters this evening. And look for the Forage Council on Facebook, and we'll post this recording soon. Thanks for joining.
Thank you, Anna. This is Keith Johnson. I really appreciate those of you who did participate tonight. Anna, you did a great job. Nick, Travis, thank you very much. And really do hope that you take the time to get that QR code or the sheets that might be available at the places that are there in person, because we will use this information. But thank you very much for your participation. And again, I want to thank Crystal Paris, was with us through the time that this was developed. She's the extension administrative assistant here at Purdue University.
And our generous sponsors as well. It took a lot of work to pull off this program, so thank you all.